We continue with question 4. We do question 4b. Prove that the triangle ABC is right angled. A is equal to 16, 1, -2. These are position vectors. And then B is equal to, okay, no, these are not necessarily position vectors, these are coordinates. So A, 16, 1, -2, coordinates in space. B, -9, 1, -2. C, 0, 1, 10. To check that these guys are, the triangle formed by these 3 points is right angled, we need to show that the distance in sums has a relationship of the Pythagoras theorem, which is either a squared plus b squared should be giving us c squared, not as position vectors, not as points, but as vectors in between points. So this was just the Pythagoras theorem I was writing here. But because they'll be vectors, they won't come out as A, B, C. They'll come out as A, B, B, C, A, C. But remember, I want to check if this is satisfied. Or you can as well check if between two vectors there's an angle 90. So we'll go for the Pythagoras theorem. So what is vector AB? Vector AB is -9 minus 16, 1 minus 1, -2 minus 2, which is equal to -25, 0, and 0 again. Then the vector AC, when forming the vector, you are subtracting the inner coordinates minus the first ones. So 0 minus 16, 1 minus 1, and 10 minus 2, giving us -16, 0, 12. And then vector BC is equal to 0 minus 9.
Mr. Keith,
Hello.
why are we subtracting again?
We're looking for the vectors now that are connecting the 2 points. Remember we said that if I have a point here and there's this line, to find a vector between the line, between the 2 points, I'll be subtracting the coordinates from this vector here, from this position vector, and the coordinates from this position vector, for you to find a direction vector. Okay. Then,
Sir,
hello.
kindly repeat what you just said.
So for you to find the vector in between 2 points, the vector you're looking for in between 2 points is a direction vector, telling us how you are moving from one point to another. Which direction are you headed? If I'm moving from here to there, then the direction is like this. If I'm coming from here to this point, the direction is like this. I know the difference. If this is U and this is V, then the difference is that U should be equal to negative I mean, v should be equal to negative u. So the reason why we're subtracting the inner minus that, we're assuming that we are moving from A going to B, moving from A going to C, moving from B going to C. So we have done 0 minus minus 9, then 1 minus 1, and then 10 minus minus 2, giving us 9, 0, 12. Okay, we have found the vectors. Now we need to check if this is satisfied. So suppose we call this guy P, suppose we call this one Q, and suppose we call this one V. We want to check, or let's call it R. We want to check now if there will be a relationship of this kind. So let's get P squared. P squared is the same as A, B squared, okay, which is equal to, you square the inner components. So we'll have negative 9. Oh, that's gone the other side. So we'll have negative 25 squared, which is equal to, okay, for the sake of showing working, 0 squared plus 0 squared, giving us, no, this is 25, 625, is it? 625. Then Q squared is going to be AC squared, which is negative 16 squared plus 0 squared plus 12 squared, which is equal to,
Excuse me, sir.
hello.
At this point, does the 625 cease to be a vector?
At this point, it becomes the magnitude. The magnitude squared. It will give the same answer because of the squaring. So 256 plus 12 squared, 144, giving us 256 plus 144, 400. And then the other one, R squared, which is BC squared. This is 9 squared plus 12 squared plus 0 squared. So we have 81 plus 144, giving us 225. So as you can see, if we add Q squared plus R squared, we're likely to get P squared. So let's see, 400 plus 225 is equal to 625. So because the Pythagoras theorem has been satisfied here, it means that triangle ABC is right angled. Where does the 90 lie? So we need this angle, so we'll sketch it. So let's put it on the other page so that we can use it to get the other things that I mentioned in the question. So the triangle will look like this. Since it's right angle triangle, hello?
The previous board, we were trying to find the vector. Was that the magnitude vector was squaring, right?
Yes.
Now, why is it that like for the 25, we're not doing the square root instead? Like why we square and then we square root?
Because we have squared it.
Don't we like usually do, for example, a
It's supposed to be the square root of negative 25 squared. Then we squared this. So the square root won't appear because of this square.
Oh, that makes sense. I didn't see that part.
Okay. So the square on the left is cancelling the square root on the right. So now we sketch. We are saying Q, which is AC, is the side giving us 400. So you can say A, C, and then A, that is AC, and then another side is BC, another small size, it's BC. Then I haven't labeled well. So we'll have, let me check, we'll have A here, the longer one, AB, okay, AB. So this will be C, okay. So we have sides, AC is the square root of 400. So now when you get the sides, since we have them as squared, to get the actual sides, we'll have to be square rooting these numbers. So square root 400, since we're having Q squared is equal to 400. So what is Q? Q will be 20. So that will be AC. So AC is 20. What about BC? BC squared is 225. So R should be 15. So this is 15. And then the other one is 625. So it's supposed to be 25. Okay, then what's the question? The question is,
So I'm having a question before you proceed. Like when making the sides, is there something that you're supposed to follow when making the A, B, B, C, and C, D? I mean C, B. When making the sides from the vectors.
Yes. You're taking the sides according to the way you found the distances. So for us to find 225, we have moved from B to C. So it must show on the triangle that is from B to C. So that we find the right angles in between the vector.
No, not this part, like when we're just beginning here, when making the sides, like.
No, the beginning does not matter.
AC. Oh.
It doesn't matter there. Okay, so find the perimeter of the triangle. How do you find the perimeter of the triangle? You add the lengths of the sides. So 15 plus 20 plus 25, which is 40, 60 units. Then find the area. Area is half BH. So half 15, H is 20, which is the same as 150 units squared. We are talking about area. Then what else? find the size of the internal angles. We've got two methods to use here. We can use SOHCAHTOA. We can as well use the sine law, or I mean the sine rule.
Sir,
Hello.
yes, where are these numbers 25, 20, and 15 coming from?
They're coming from the square roots of these numbers that we got here. So you're looking for size P, Q, R. And what you have is P squared, Q squared, R squared. So you square root to get what you want. What was the other question? Seems like we had so many questions. Okay, it was the
So
same.
what was your main aim for squaring the vector side, the magnitude side, the AB? For example, AB squared, vector AB squared. Why was it like that?
Trying to check if the Pythagoras theorem is satisfied for the triangle to be right angled. And the Pythagoras theorem talks about the squares of sides in relation with their sum to give us the hypotenuse, adjacent, opposite. To find the internal sides, we already have the other angle is 90. Let's call this angle alpha, and the other one beta. I'm saying that you have two options. You can use sine rule or SOHCAHTOA. SOHCAHTOA is telling us that if you use sine, suppose you're looking for alpha, sine alpha should be opposite over hypotenuse. So in this case, we'll have sine alpha is equal to, opposite is 20, hypotenuse is 25. So you get sine alpha is equal to 4/5, and so alpha is sine inverse 4/5. If you want beta, you can still use the same sign, or now we use cos. So say cos beta is equal to adjacent over hypotenuse. So adjacent is 20. Aside from question 1. So 20 adjacent over 25. So we get cos beta is equal to 4/5. So beta is equal to cos inverse 4/5. The value you get here must be the same value you get if you use sine. Sine beta is equal to opposite, which is 25, which is 15. Opposite 15/25. So beta is equal to sine inverse of 1/5. Oh, did I say 1? 3/5. 3/5. Let's confirm. I have the calculator here. Sine inverse of 4/5. 4/5. 53.13. 53.13. Then the other one, what if we use cross product to find it? We'll check. So we are here to learn. We'll check.
Sir.
Hello.
The angle you found, the inverse of 4 divided by 5, it gave you 53. It's giving you something else.
This calculator here. Sine inverse of 4
Mine is
over
giving
5.
59.
Now it's 50.
53.
There must be something wrong with your calculator.
Mine or his?
His.
Easy.
Exactly. I trust my calculator.
It's 53.1.
Exactly. I hope you are doing the inverse and not the direct sine. Then what about cos
I'm
inverse?
doing the inverse.
Then maybe calculator is in rads.
36 over 8. That's 36.8.
So 4 over 5, 36.87. So here is 36.87. When I round off degrees. Let's see if we get the same with sine inverse. Sine inverse of 3 over 5. Exactly the same. 36.87. So I'm saying that you could choose to go by cos, go by sine, or tan. You still get the angles inside. Or you use sine rule. If you use sine rule, look, I'm giving you a variety here because in the exam, the temperatures differ. In case the temperature is too high, you forget SOHCAHTOA. At least you can remember the sine rule and you still get the correct answer. Sine rule says if we have sides A over the angle, it will be the same as having side B over the angle. So we have an angle here which has the opposite side. So we have 25, the side, and its angle is 90. So we can use it. So let's see. If A is 25, then the angle is 90. Is equal to B, let's pick alpha, 20 over sine alpha. Sine 90 is 1. So we are dealing with 25 over 1, which is equal to 20 over sine alpha. Cross multiply, we'll have 25 sine alpha giving us 20. Then we divide by 25, divide by 25. So we'll have sine alpha is equal to 4 over 5. Exactly what we have here. So you can see that alpha is going to come out to be 53.13 degrees. The same thing can happen to beta. You get 25 over sine 90 is equal to 15 over beta. You get the same angle. Cosine rule does not work when you're dealing with a right angle triangle. You should check that. Now let's check. Somebody asked, what could happen if we used, could we get the same area if we used let's see. If we use the cross product, you pick two angles. So let's pick. Suppose we pick AC cross AB. We're going to deal with I, J, K, and what are the sides?
So can't we go to the next page because
No, they won't sankana. Will be done in this space. Don't worry. So the angles, I'm looking for the sides. So I've gotten A, AC, AB. So AC, negative 16, 0, 12. Negative 16, 0, 12. And then also I've gotten AB. AB, negative 25, 0, 0, theta. Negative 25, 0, 0. So this is the determinant. So we have I, and then we cross, so we get 0. Minus J, we do the crossing. So we get 0.
Wait. What are we finding exactly here?
Determinant. No. Look, when you miss a class, what you do is that you wait for the video. When the video is sent in the group, you watch it so that you come up with a gap. Because what I'm seeing is that there are some people here who missed that class. And so the issue of the determinant of a 3 by 3 has come in strongly.
No, sir, we didn't miss last time. What I'm asking is, what are we using the determinant for? What are we using it for? What are we finding?
Okay, good. The determinant is, look, we don't just want to get the, when getting the cross product, we want the cross product that can give us the determinant. The determinant will be a vector. Then we'll get the magnitude of that vector for us to find area.
Oh, yeah. I'm trying to use the first product to find the area.
Yes, so I want to see. So there's a question to say, can we still get the same area if we use the cross product? So I want to confirm here, so that we can know.
Okay, carry on then.
Okay, so we have I0, negative J, 0 plus 25 by 12. 25 by 12, 300.
So why aren't we adding BC here?
Aren't we adding BC? Okay, we'll add BC here we need. You can see the cross product for finding this guy does not require all the 3 vectors. Just needs 2. The one which requires all the 3 is not the area. Unless we are talking about the parallel pipe.
Excuse me, sir.
Uh-huh.
Sir, that 300 is indeed supposed to be negative.
Positive. Upper 0 minus positive.
All right, sir.
Then the other one, Papa 0. Correct. Except that when you use the cross product, you must not forget to divide by 2.
Why?
Still same concept, because the issue of the area under cross product comes from the parallelogram. The parallelogram contains 2 triangles. And so if you're talking about a triangle, you're getting the half area of the parallelogram for us to get to the area. So for it to be area, this must be divided by 2. Now it's a vector inside, so we're getting its magnitude. So we'll have 0 squared plus 300 squared. It's negative actually. We square it and then divide by 2. So the square, 300 squared square root. So 300 squared You get 90,000, then you square root it. You get 300. So you have 300, then divided by 2. You get 150 units squared. So you can use the cross product, but please don't forget, the cross product is for the parallelogram. So to get the area using the cross product, you divide, if it's for the triangle, you divide by 2. If it's for the parallelogram, you don't divide by 2. You just get it, whatever you get there, you call it the area. Because we said that the triangle falls in as a result of having broken the parallelogram into 2 pieces. Joseph, does it mean that you want to ask a question? Or you're just feeling nice? Where is 300 coming from? 300 is coming from 25 by 12 under the component J. I'll remind you well how to get the determinant of a 3 by 3 under matrices. If you have forgotten, so I remind you here. The first one, when you get the I, you cancel here, cancel there, and then you get the determinant of a 2 by 2. So it says 0 by 0 minus 0 by 12. You move on, minus J, and then cancel this row and this one. So you have negative 16 by 0, 0. 12 by negative 25, you get 300. And then negative for subtracting makes this 300 positive. And then the next one, you cancel this guy and this guy. So you have negative 16 by 0, 0, 25 by 0, 0. So that's why it did not appear. It's supposed to appear as 0K.
Mr. Keith, why did you choose AC and AB, and why are we dividing by 2?
Mr. Keith, does it mean that if we choose AC or BC and we do the cross product, we should get the same answer?
Exactly.
All right, thank you.
So the choice, I just made that choice. You can also make any other choice as long as you're operating within the 3 vectors.
Excuse me, sir.
And if you use all the 3, it must come out direct as the 150. Yeah,
Oh, sir, as we are starting this question, I heard you mention another alternative method you can use to actually to prove that this triangle is a right angle triangle.
I said that. Oh, yeah. I said you can also check if in between N two sides, the angle is 90. That is if you are equipped on how to check.
Yes, so my question now is, apart from using this Pythagoras theorem, I don't know if you can explain the other method so that maybe we may choose which one might be easier to us,
Cos theta is u dot v over this. So since we have the vectors given, you can pick in each vector, do the dot product, divide by the magnitudes, and then solve for theta as an angle through cos.
But sir, why were we using calculator?
This is 1120. We use calculator. 1100 is where I don't use calculator because there's no topic statistics and probability. In this course, there's a topic called probability and statistics, which someone can only survive if they are calculators. If you are given
at first you made our lives miserable.
Yeah, they can still be even in test 2, in the test 3. If they say no probability analysis,
That's
then
how
they
way.
will not accept
Does
it.
it
At test
does it
3 is
mean that
hard.
sir, does it mean that if we carry calculators for statistics and probability, we can still use it for other topics?
But you have it. Even you have a calculator in your hands, and you are looking for 300 times 750. You can use your calculator. No one will know that you have used it. But the fact that somebody knows that you have a calculator, they can't ask you to multiply 6 by 3. They know if this guy forgets, they will punch. So you are free. Once you have it, then you use it anyway.
You mean there'll be test 3 open?
Yeah, they may be test 3.
But some were told that the CA over math is done. So how is test 3 coming in?
For you to write the exam, topics must be assessed in tests and assignments before they can be assessed in the exam to give you a clue of how they ask questions under those topics. That is the university policy.
If even test 3 results will be added to our CA, isn't it?
Exactly.
Okay, then that's much better.
Questions to answer, let's proceed.
So now we are answering because we are logging out and log back. So log
Mr.
out
Keith,
and come back.
this method you are showing here, the last one, is the same as the half BH, right?
Yes. Exactly the same. So you log out and come back quickly.